Well, greetings students. We're going to continue on our drill tap bore project. This will be considered session number 3, and I believe we will complete this project today with basically the boring, the counter boring, and then the threading operations. All right, so let's get started with this. The first thing we want to do is we want to bore out these 3 holes. We have a pilot hole in here for this, so we're going to go with that and we're going to bore these out. So we'll start out with this first one here, the 921-9 hole. And so I'm going to go up here and I'm going to right click and go to Mill Tool Pass and grab Contour. And it's asking me to create a chain here for this. Double check, make sure that WCS is top, T-plane top, C-plane top, and 2D. And then a C-plane up here, of course, and wireframe. So now we're ready to do this, so I'm going to go in here and I'm going to grab that. Now that's going to be doing counterclockwise, which would be Klein milling on this, and there's really no need for a good finish on this. We don't even need to put a finish cut on it at all. So I'm going to reverse that to make it a conventional, all right? And you do that too here, and then I'm going to hit OK. So now we see that it says contour here. We're going to be choosing the 1/2 inch end mill again, and the holder will be the same as what it was last time. The cut parameters will be activated now, and you are going to say cutter comp right, okay, for conventional. And it's going to be computer here. It's going to be 2D here. And we're not going to leave anything on the walls or on the floors. We're going to basically bore this all the way through. We will definitely need depths of cuts, so we're going to go ahead and put 1/4 inch increments in here. And our lead, and it should be step down, keep tool down here. Lead in, lead out. Basically should be different than this. And you know, I was just thinking about this. I think I need to go back and say no here or cancel. And I think what we have to do is grab the center point. So we'll do this again. And that's something to remember. When you are doing a bore, it's not a bad idea if you're using contour to pick where you want to start this. If you're doing pocketing, it really doesn't matter because Mastercam will choose where it wants to start. So let's go back in here again, and we'll right click here and say Mill Tool Pass and Contour a second time. And this time we'll grab the center. So I'm going to come down in here and hover over the center point right there. And then I can go back to the chain, and it is already going clockwise or counterclockwise. I'm sorry, clockwise, which would be conventional milling. Cutter comp right, and we will hit OK here, and then we're back to the contour. The tool is going to be the same. The holder is going to be the same. Cut parameters, as I said earlier, is going to be cutter comp right in this case. Computer is going to be what's active up here, and 2D here, nothing on the floors or on the walls. Depth of cuts, as we said, would be 250, and that's good there. Keep the tool down and step down. Lead in, lead out. Now, because we are choosing a center point, we want to lessen our ramp in and ramp out. This will not work well here, so we should make this 0.075, and then this one should be 0.075, and our angle here should be 20 degrees. All we have to do now is make sure we transfer this to the other side. So you have 0.075 here, which is 15%, and there is no ramp height added here. And then on the arc, we're going to go 0.075, 15%, and 20 degrees. The next thing we want to do is skip multi-passes and tabs, linking parameters, 0.1, 0.1, this should be 0. And we should have a depth of, since we're going down 1 1/4 inches, we want to go more than that. So we're going to go minus 1.35 That's 100 thousandths extra depth. And make sure that these all say absolute. Last thing is going to be flood coolant on and OK. So now we can look in here and we can see we have these smaller arcs going in and out. So let's just test this out and see how this looks. So we'll go ahead and we will okay, it did not choose the center, so we're going to stop this and go back to the parameters and make sure that we have that activated. Lead in, lead out. We want to make sure we have use entry and use exit point and exit point. Now we should have it correct. And you can see that there's a small teardrop style ramp in and ramp out. So let's try it now and see how that looks. And there it goes. And we can watch this down here at the lower left and see the depths of cut. 450, 675, 900, 1 inch 125, 1 inch 350, and it should come right out of there. And it does. Very good. All right, so we're good with that one. Let's go ahead and do the next one. So we're going to, again, right-click up here and say Toolpath and Contour. Now we can't copy and paste this because we have a different location. So if you're wondering why we didn't do that, that's why. We'll go to the center this time. Make sure we pick the center first, and you always have to pick the center first or it won't take it. And then we can do the chain itself, and we need to reverse this. So we're going to go down here and reverse this to make sure it's going in a clockwise direction. Cutter comp right. Hit OK. And again, we're going to be back to contour, tool being a 1/2 inch, holder being the same as it was before. Cut parameters. It's still going to be cutter comp right. It remembers that 2D computer. Nothing on the floors or the walls here. Keep the tool down. Everything looks good here. Depth of cuts. At this time, we're going to do depth of cuts again, just the same as we did the last time. Step down, keep the tool down. Lead in, lead out. We're going to keep this the same. Just make sure you transfer it over. And of course, this has to be active. Use entry point, exit point in order for it to take it. Linking parameters, it's going to be basically the same as before. The top of the surface is 0 and it's minus 1.35. Absolute, absolute, absolute. Coolant should still be on, and it is, and I'm going to say OK. So then we'll do our last one over here. And again, I'm going to right click, Mill Toolpath, Contour. And we're going to, again, grab the center point in here first. There. And then we're going to do the chain. Again, it's came out right this time for that, so we're going to say OK. And now we're going to go to pick the same tool, the same holder, cut parameters. It's still going to be cutter comp right, and everything is good here. Depth of cuts, 0.250. Keep the tool down, step down. Lead in, lead out will be the same. Linking parameters. We're going to do the same thing as we did before. 0 point for this and minus 1.35. And that should take care of that. And I think the coolant is pretty safe to sure that it's on. Hit OK. And now we have our 3 bores. It's probably a good time to just do a double check of everything. And in order to do that, you have to click on Machine Group 1 up here so that it does all of this. If you pick something like in here or here, it's only going to do that. You want to make sure that you start out from the very beginning and check this out. So that's what we're going to do. And we're going to go in here to verify, wait for it to boot up, and make sure our feed bar or speed bar is just a little bit slower. And you're going to see this go ahead and machine all of this out. All right, looks good. All right, so if you have any questions about whether it's all the way through, you do the dynamic rotation and then left click and hold it down, and you can see that our holes, our bored holes, are all the way through, and that's important to check that. All right, we'll get out of here. We'll go into isometric, and now we're ready to do our counterbore. So since we finished this one last, we'll go ahead and do the counterbore next. So we're going to basically be using the same 1/2" tool for this, but we're going to go to a different direction. We want to make sure we climb mill on this to give it a nice finish, and we want it to be more accurate than the bore through, since the bore through is only for the minor diameter of the thread. The bore itself, the counterbore itself, could be like a bearing pocket, so we want to make sure that we give it a good finish and we have a close tolerance on it. So again, right click up here to mill tool pass. We want to do a contour again, and we will need to use, of course, the center point again. So I'm going to come down here and grab it a second time here, and then the chain, I'm going to grab the counterbore here, and this time we want to go cutter comp left, and it'll be counterclockwise, so that's correct. And I'm going to say OK, and the tool is going to be the same, the holder will be the same, the cut parameters will be cutter comp left, right? We want to make sure it's left, the computer and 2D. We are going to leave 10 thousandths on the walls and on the floors, okay? So that we can skim that off at the end and give us a good finish. Depth of cuts, definitely we're going to use depth of cuts in this. It's going to be 0.125 increments, and nothing needs to be done down here. Keep the tool down, step down again, the same as before. Lead in, lead out will be the same thing exactly as what we had before. Make sure that these two use entry point and use exit point are checked off, as you see here. Linking parameters, we have a 0 for the top surface again, and the depth is going to be minus 0.25. Now, even though we're telling it minus 0.25, it's going to adjust with our stock material on the floors and on the walls. So we're good there. So we'll make sure the coolant is on, and it is, and say OK. So now we'll just double check this to make sure this is doing what it's supposed to do. And you'll look down here and you'll see that it's 0.12, going the correct direction. We want to do counterclockwise, climb milling. And now look to go see if it goes down 240, so that means it's leaving 10 thousandths on the floor. All right, that looks good. So now all we have to do now is just copy and paste the same one, the same operation here. So I'm going to left click on this and say copy, come down here and click on the red arrow and left click and say paste, and I now have put that same operation a second time. Now I'm going to go into the parameters though, and I'm going to make some changes here so to make sure that we are going to get the rest of it skimmed out. So the cut parameters are going to be changed to 0 point for the stock and the walls and the floors. So this will allow this to go all the way down and machine this out. Depth of cuts, we want to keep the tool down, step down, and we're not going to have depth of cuts anymore. So it's just going to be basically coming down one time and going around. So we don't need depth of cuts. That's going to eliminate any kind of steps. Lead in, lead out is going to be the same as we've had before. Again, we're going to be using the use exit and entrance point. These values will all be the same. And then the linking parameters will be the same as well, minus 250. All these should be absolute, and the coolant hopefully is still on, and it is. All right, so now we can take a look at what this is going to do here. So it should come down minus 250, so we'll watch this, minus 250, and it should go in a counterclockwise direction. And we're looking good there, so I'm going to say OK here. And now we'll do the next one. So we're going to right click here and say Mill Tool Pass, and we're going to say Contour again. We're going to start out with our center point here. Make sure we grab that, and then we'll do the contour, the chain next, and we'll reverse it to make sure it goes the right direction. And we're going to say OK here. And again, we're going to go to the same tool, same holder, cut parameters will be cutter comp left, and there's going to be 10 thousandths, 0.01 on the walls and the floors. And our depth of cuts are going to be back to 250. I'm sorry, 0.125. So it remembers that, so we're good there. Step down, keep the tool down, that's good for each rotation. Then our lead in and lead out, we'll be using the same thing here with these two checked off and 0.75 on both sides. Okay, and then linking parameters, we're going to make sure that we tell it to go down minus 0.250. And the coolant is still on, and we're going to say OK. And we'll just double check to make sure that this is doing the right thing here. So we're down 120. And now we're down 240, leaving 10 thousandths on the floor. All right, so that's good there. And now we're going to copy this, and we're going to paste it down here to create our final cut. We'll go into parameters. The tool will be the same. Holder will be the same. Cut parameters will be the same, but without any kind of material on the walls or floors. So we're going to get rid of this and say 0 point. Cutter comp left, everything's good here. Depth of cuts, there is no depth of cuts here, so I'm going to uncheck this so it gets rid of that. The lead in, lead out will be the same. All right, so everything's good here. And the linking parameters will be the same here. I did remember this time, the top of the stock, which is nice. The depth, of course, is still minus 0.250. We're just going to make one cut. And the coolant is on, and we're going to say OK. So again, we can check this one and make sure that that's good. And it's good to make a practice of checking things so you know if you're going to get the right results. That's minus 250, so we're good, and we're going cutter comp left. We're climb milling here to give it a nice finish. All right, say OK on that, and we're looking good there. So then we'll do our final counterbore here, and we're going to again go up here and right click and say Tool Pass and Contour again. Again, we're going to pick the center of our part here, and we're going to do our chain, and it's going the correct direction this time, so I'm going to say OK. Tool path, again, is contour. Tool is the same. Holder is the same. Cut parameters, cutter comp left, so that's all good. And we're going to leave 10 thousandths, again, on the walls and floors. And our depth of cuts is going to be 0.125. It remembers that. Lead in, lead out. All these items are good. We're going to just make sure that it crosses over to both sides. Linking parameters. This again should be 0 here, and this should be minus 0.250. And I think the coolant is probably still good yet. Absolute, absolute, absolute. And we're going to say OK. And then we'll double check this to make sure we're getting what we want. There's the first one, 120. And then 250 or 240. Okay. All right, we're good there. So now we can copy and paste. So I'm going to left click and say copy. And then come down here and say paste. And then I'll go into the parameters again, and I will go back and do the same thing I did before. Same tool. So it's a 1/2 inch flat. You have to watch that, it moved. Holder will be the same. Cut parameters. We're going to take off the 10 thousandths now, make it 0 and 0. Depth of cuts, we're not going to need that. Lead in, lead out. We will need everything the same here. Linking parameters will be the same. And make sure they're all saying absolute. And the coolant probably still is on, and it is. And now we'll just check this last operation here to make sure that everything is good here. It's going down 250. Cutter comp left. Okay, looks good. So now, because we have done quite a bit of work here, I think we should go back now and double check the whole operation to make sure that everything looks good. So you bring your scroll bar up here, grab machine group, click on verify, and the speeds and everything should be the same, and just go ahead and sometimes that happens and I don't know why. We're going to get out of there. You have to, if you pick machine group 1, it should go right to the beginning. So in other words, there should be no areas highlighted down there. So this should give me the whole operation. For some reason, it's not doing it. All right. All right, so let's click on group 1 and then go back on machine group 1. Try it again. See that's a glitch in the software, so that's not something I'm doing. And let's see what happens now. Might want to slow it down just a little bit, just so you can see everything clearly. Taps all the holes, drill through. Bore through. And now our counter bore. And that's basically it. And if we go to top view, we can take a look how this looks. And if you right click here and say dynamic rotation and just slightly rotate this to there, you can see pretty well what's going on here. Okay. And if you want to, you can also do the rotation underneath to make sure that everything is through again if you wish. All right, so that's good. Let's go back to our main page, and we're going to put in here isometric, and we are going to do our final thread operation. So we finished up here, so I'm going to go ahead and start the threading operation here. I'm going to right click, say Mill Toolpaths, and then come all the way down to where it says Circle Toolpaths and choose Thread Mill. Now it's looking for the chain or a chain to represent that thread. So the dotted line here represents the thread. So I'm just going to come down here and get close to it and click on it. And notice it has the arc and it's seeing it as 1 inch. And that's exactly what this is. It is 1 inch. So I'm going to say OK here now. So this is handled a little bit differently than when you're milling something. So the toolpath type again, now they're saying it's thread mill, which is correct. Our tool, we're going to pick up the 1/2 inch thread mill, okay? And our holder, we will fix this, okay? And we can have this at like 2.250 or 2 inches, 2.0. Let's see if it'll give us 2 inches, and it does. And then our cut parameters, it's showing you here a picture of the thread mill. It's still giving you the number of active teeth. And the way, you really should do this, since this is 18 threads per inch, which is 0.055, I just want to make sure that I'm right on that. Let me just double check on that to make sure. I believe it's 1 inch 12. So it should be 1 divided by 12, which is 0.08333. So that's got it correct. If you multiply that times 21 active teeth up here, that gives you a depth of 1.75. What we want to achieve here, we want the tool to come all the way down into the bottom of the piece, and we want to make one rotation. So to get one rotation, we have to penetrate at least 1.350 plus. So we know we have enough active thread teeth here to do this job, okay? So that's all good there. The compensation is computer. You have control, wear, reverse wear, and off. This is an ID thread. This is extremely important that this is activated, okay? It is also a right-hand thread because we're going to go in there to the right and go down. And we want to make sure we go from the top to bottom. So we're going to check that off, top to bottom. And you can see that it goes all the way down and rotates, okay? So it's top to bottom. It's conventional cutting direction, and the spindle direction is clockwise. So make sure those things are correct so you get the right outcome. Then you have your lead in and lead out. Now the standard is an arc distance or clearance of 100 thousandths, and the arc sweep is 90, which is what this is here, and that's fine. You don't need to change anything there. You do need, however, to make sure that you start the rotation at the center of the bore. Very important here. And then you want to start at the center and you want to end at the center. So these two must be checked off. There's no multiple passes, no tool axis control, no limits, no hole segments, linking parameters. Here we're going to make sure we make this absolute, 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 absolute. We want to have a retract of 0.1, not 0.5, which is where the feeding will begin. Feed plane 0.1, top of the stock is 0, and the depth is 1.375. I'm going to go this time. Okay, a little bit deeper, and it should be minus here. So minus 1.375. I'm going to make sure that our coolant is on, and it's not, so we put it back on and say OK, and then we'll take a look-see how this works out. So it should go all the way down to 1.2 250 and rotate until it gets down to 1.375. And yep, and then come right out of there. Now you may want to say, okay, well, I want to make sure that this looks good in real life here. So I'm going to go back and I'm going to grab machine group 1, click this, and I want to go through this program one more time and make sure that that the thread mill is doing what it's supposed to do. We should see threads in here. And then the thread milling operation. Okay, so now if we rotate this, so let's go to dynamic rotation. Let's rotate this and make sure that we've come all the way through to the end of the piece, and we did. Now we can go back up to top view, and this is important that you take a look at where this cutter is actually cutting here. Is it cutting this right here or something else? So you can start to see the thread right in here, so it looks like it's going to be correct. And so what I'm going to do is slow this down even more, and I'm going to click the double here and start this up and see if it does what it's supposed to do. And we're going to have to rapid through this again. And I'll have to stop it in time. Hopefully I can. It's hard to actually get that. What we want to do is slow it down when we get to that point. Let me put this in isometric and see if I can catch it in time. Okay, I want to catch this in time here. Step forward. Now, at this point we can do a dynamic rotation. Make sure that it looks like it's going to go all the way through. We can zoom in on this and just click on step forward here and take a look at the results. So it looks good to me. It's starting in the center, ending in the center. The threads are in there. And if we go to the top view, we can see that we have the threads going all the way out to this diameter here. So everything looks good there. We're going to go back to isometric and fit, and then get out of there, and then do the final 2 threaded holes. Again, I'm going to go up here, right click, mill tool pass, come down here to circle and thread mill, and it's asking me again to pick the correct diameter. There it is, arc 1 inch, that's good. Okay. Tool is going to be still the 1/2 inch. Thread mill holder is the same. No stock cut parameters. These will all be the same. Nothing should change here. ID, right hand thread, top to bottom, conventional clockwise. Lead in, lead out. We're going to go with the standard. Start at the center, end at the center. Linking parameters. All these are good except for this. We're going to go minus 1.375. Okay, absolute, absolute, absolute. Coolant hopefully will be on this time, and it is. And we'll go ahead now and just make sure that this looks good. Goes down. Makes one complete rotation to 1.375. And then out to center. All right, excellent. Last one we have to do now is this one here. So we'll again go up here, right click, come down to mill tool pass, and come down here to circle tool pass and thread mill again. Again, we're going to pick this thread diameter here, and that looks good there. We're going to say OK, and go through the same process as we did before. Cut parameters will be the same. Nothing's changed here. Lead in, lead out will be the same. Nothing should change here. And linking parameters, minus 1.375. And that should be it. I'll say OK, and just make one double check here to make sure that this is all good. Whoops. Another thing you can do here is you can hit the top view here, and you can zoom in on this to make sure that that tool is going right to this diameter. It's a little easier to do it here in backplot, so we'll try it again. If you look at that, it's right on the line, all right? So that's telling you it's cutting right into the 1-inch diameter wireframe representation of the thread. All right, so everything looks good here. I'm going to put this in isometric. I'm going to go up to Machine Group again and click on this to make a final check. I can speed this up now because I've watched everything, so I'm going to go ahead and speed through this. And then take a look at the threads, make sure everything looks good here. Again, I can hit dynamic rotation, rotate, make sure that everything looks good all the way through here, and go back to isometric, and then get out of here. And this is the time you really definitely want to make sure you save this. So I'm going to go here and say fit, and I'm going to hit save. And that completes our operation for the drill tap bore. All right, so we're going to leave it. I'm going to let you work on this on your own a little bit. Take a look at it. Make sure you have these steps correct. And I'll talk to you soon. Have a good day.